regional, and national levels. He is also a fellow AICHE and the founding chair of its educational division. So now I'm happy to turn it over to them.
Great. Thank you, Walter, and thank you to Elsevier for the opportunity to talk with you all today. So we're talking today about some practices that we found have been effective in teaching engineering undergraduates and in an online mode. And all of what we're talking about really precedes the events of what happened over the last several months in the rapid transition. So what we're going to be talking about more specifically are some of the summaries of what we believe to be effective practices, much of which is confirmed in the engineering educational literature, as well as our experience in using a lot of tools, both in our face-to-face courses, but primarily in our distance and online courses. So we'll be looking at three main areas of effectiveness, looking at creation of content for the online mode, methods of improving student engagement, and also facilitating student success. As a brief justification of why we're talking about this, I've always been someone who's a very technology oriented, and when starting with UK, I had the opportunity to start doing things more actively with technology in the context of teaching. I was kind of thrown into the fire during my interview, where I had to give my seminar by distance without knowing that was going to happen, or being able to think through the difference in the modality of teaching or lecturing by distance. But that went reasonably well. Actually, it must have gone well since I got a job. And since then, I've been steadily working to best integrate current video technology as well as other elements into my teaching, and started teaching specifically online classes. Had done distance learning before, but it's fully online classes started in 2017.
Hi everyone, thanks for joining us. I am Sarah Wilson, so I've been teaching at the University of Kentucky since 2015. And since that time, I've really worked on integrating video and technology into my classrooms. So I do a heavy flipped classroom for our theory-heavy content, and I do more hybrid courses. So I've done a hybrid course for computational-based content. I've also co-taught a couple online courses with David, so a fully online summer thermodynamics course. And then this summer, I'm working on developing and teaching an online bourbon production engineering course. So we have two versions of that course, and that non-engineering version is offered right now. It's up and running. In addition to teaching, I'm also involved in educational-based research, so looking at communication and really understanding how to best target different audiences for communication. So that's something that's important to be looking at and thinking about as we're developing online teaching tools. Additionally, I'm interested in engineering student mental health. So especially with moving off campus, I think that's a big and important factor for us to be considering how this transition online has affected engineering student mental health. So as we're going through this webinar, what are we going to do and what won't we do? So what we don't want to do as we're going through this webinar is provide instruction about how to use specific platforms. All of our different institutions have different platforms that are available to us for free, and we want to make sure that what we're talking about is going to apply to all of our different teaching methods that we might have and all of the technology that will be available to us. We want to make sure that we're sharing things that we've learned from successes and failures in teaching online and through distance learning, so that you can use those to better create the courses that you're putting together.
So what we would expect, we would like for you to gain from this webinar are an ability to apply some approaches that maybe you've not tried before for online instruction, as well as to be able to identify and adapt resources that would be useful in improving the quality of your online instruction, whether you choose to do that as a deliberate choice or if that's a choice that is forced upon you. But to get started, before we get into the real content, we'd like to get a sense of where you all are in terms of your experience with teaching online. So we've posted a poll, and we'll hold here for a few seconds as we collect your responses.
So we have about 20 responses in, and it looks like about 60% of you have never taught an online course, whereas some of you have taught a fully online course. So 3 of you have taught a fully online course, and 5 have taught a hybrid version of a course.
So it looks like we have the right audience, although I suspect most of you who have not taught prior to February or March have now gained that experience.
So what we're going to do is get started with talking about some of our recommended effective teaching practices. So these are things that we've learned just through putting together online courses and practices that we think would be effective for you to implement in your own courses. So one of the big things that you're going to want to do with an online course is make sure that you're really communicating with your students. So communication is key for both faculty and for students. So you want to make sure you're communicating to your students, but you also want to make sure that students are communicating with you. So things to be thinking about in communicating with your students, make sure you set up an order of operations for the course. So where should they be going to get specific information? If they're unable to find it, when should they be reaching out to you to make sure that you're able to help them? One of the big things that we recommend is giving students a demonstration of the technology and the course organization. So oftentimes when we're establishing our courses, we think about how we want them to be organized and how we want our students to see them. But if we never show our students how to do that, then oftentimes that organization can be misunderstood by the students and they might be looking for things in the wrong places. You want to make sure that you're setting clear expectations and deadlines within your course. And you want to make sure that you're being flexible with that so that if there are things that come up, you can adapt to student learning. In doing that, make sure that you're focused on the student learning outcomes. You want to make sure that you're testing the learning outcomes for the course and not getting caught up in too much of just kind of the nitty-gritty of assignments just for the purpose of making an assignment. You want to make sure you're considering your pace and how learning occurs. So if you're giving lectures and you want students to complete the lectures, make sure you're giving time between when the students are expected to complete a lecture and when they'll be tested on that material. Right? So if we think about how learning occurs, a lot of your short-term memory will happen quickly, but converting that over to long-term memory requires students to have multiple days worth of time to think about that content, bring it back into their brains before it really gets set in there. If you're testing them on content immediately after they're watching that lecture, they're never converting that content over to these long-term memories and they won't really retain that information past the course. You also want to create ongoing engagement. So we'll talk later about different options that you can do to keep students engaged within the course and make sure that they're participating and being active members of that course. In setting up communication from your students are going to have a lot of questions. So oftentimes with online courses, we're going to get a lot more emails and you want to make sure that you're being quick to respond to emails. Especially with short-term courses. So some of your summer courses will be offered on a shorter schedule. So if they only have 6 weeks to complete the course, responding quickly to emails is especially important. And then you want to be open-minded and compassionate. So obviously we're over that transition of that panic of getting our courses online, but we're still in the midst of a pandemic. You want to make sure that you're being open-minded and compassionate. If students have things that arise, make sure that you're being understanding. And just showing the students compassion as you're going through the course. So what are some different strategies that you can use to get the course off to a good start? Like I mentioned before, creating a video explanation of how you organize the course is something that's really important. So this can show students how you organize your course and the vision for how you want them to be interacting with the course. It can also provide them with information on your plan for posting videos, submitting assignments, etc. So if you're planning on releasing all of your videos every Sunday afternoon so that they have all of the content for the week every Sunday afternoon, knowing that information is really helpful. So as you're walking them through the course, make sure you're giving them that information. Often a video is more helpful than a long email with instructions. So our students won't necessarily sit there and read a long email, but getting that visual as you're talking to them about how to walk through the course is something that can be really helpful and more effective way of delivering that information. As you're going through and doing this, make sure that you're using the student view in your learning management system. That way, the students will see things the way that they're actually going to see it in Canvas and not from your perspective as a faculty member. This also allows you to see what the students are seeing within the course, check to make sure things that are organized the way that you're envisioning it, and making sure that the right files are visible to students as you're going through the course. You want to be really careful about your organization. So when a course is entirely online, they're going to have to be interacting with that learning management system pretty heavily. So make sure you're staying organized in how you put things together, as well as staying organized in how you put together your lectures. So lectures online are going to require more thought because you have to think about what the students can see as you're going through and putting things together. So make sure you're really putting effort into an organized lecture and planning that out before you start recording. Be careful about leaving silences within a video. So students can easily get distracted if you take 15 seconds to write down a definition. So oftentimes integrating in text with writing will help you to make sure that you can go through the lecture material a little bit more quickly without having those long gaps for writing. You also want to make sure that students, to alert students of where they can go if they're having technical issues. So with online courses, there's going to be technical problems that arise. And as faculty members, we aren't able to solve all of the technical problems for the entire class. So make sure students know where they can go to get help. So if students are using specific software programs, point them in the direction of the help software for those specific software programs. Also point them to their classmates. So if they're having trouble adapting to the technology, oftentimes they can get more help from their students than they can from you or another help service. And then remind students of support options from your institution. So a lot of our institutions at this point have put together very robust technology help services. So make sure students are using that and taking advantage of what's been put together by your university.
As you move through the course and are considering all of the various things that you're going to communicate with students about, keep in mind that when you're in a face-to-face class, you can often get a sense for the issues students are having just by being in the classroom with the students and observing some of the things that they're doing, the looks on their faces. But you can't do that often with an online course. And so you do need to be asking students proactively about the issues they may be having in an online course, particularly in a scenario where maybe they haven't really wanted to take that course online, as many of us will be in that situation this fall. So asking them if they have reliable internet and maybe working with the resources your university is making available for providing alternatives can be an important aspect of your inquiries. Asking them if they need additional resources like demos of web conferencing. Are there challenges that they're having or concerns with attending web conferences? Do they have to have an additional? Are they having issues watching their lecture videos or with the online quizzes? For example, a proctoring system might require a camera and they may not have a camera. So being aware of those situations early can help move the course forward. Ask them in general questions and you'll be surprised at the kind of information that they'll disclose. What are their concerns, their biggest concern? What are the things that you could do? What are the things that you can provide that would help them to be successful in the course? There are obviously limits in how you can respond to these things, but you can often help them find the resources that they need to be successful. It's worth doing this not only initially at the beginning of the course, but also continuing to do this periodically throughout the course in order to help facilitate their success.
So one of the most important things, whether or not you offer live courses or whether or not you're posting videos ahead of time, in your live options, you want to make sure that you're recording your lectures and posting them for students to watch, right? So not all students will have easy access to video conferencing for every lecture. And oftentimes technology problems are going to arise where they might not be able to join a lecture like they were planning. So because of that, you want to make sure that you're recording all of your videos so that you can post them to your learning management system. And this allows students not only to go and participate in a lecture that they might not have been able to attend live, but it also lets them go back and review content that they might have missed. So it gives them a really good opportunity to interact more with the content. And it's really not a painful thing for you to do as a faculty member to just click record before you get started. So you want to make sure that you're doing that. It's easy for us to do and it gives students a much better opportunity to get that content. In doing this, you might consider investing in a quality microphone. So the microphone is going to be the biggest part that will improve the quality of your videos for a really low cost and low effort.
When you are recording video content for your classes, keep in mind that the research literature shows that the optimal length for student retention for videos is about 5 minutes, and you can push that to 10 minutes. And in a few cases, it's necessary to keep them longer, but those short videos are going to be far more effective than a full lecture length video. If you're recording videos for asynchronous presentation on demand rather than live, take advantage of that format to keep them short, and to make them short, think about how you can logically divide them up by topic, by concept, by learning outcome, and then package them in a way that makes sense. If you're recording example problems, make each of those problems a separate video, and then give them a title that they can use to identify the kind of example that they're looking for, and they'll come back to that video a surprising number of times for assistance. In order to help keep the video short, it's already been mentioned that you should be prepared to pause the recording as you gather your thoughts or as you write things down. It's worthwhile keeping a Post-it note in view that reminds you of the keyboard shortcut for that, so that you're not having to fumble with the mouse trying to find the right button on the screen. And you should also ask students to pause the playback of these videos so that they can consider the details of what you just presented to them. And we'll talk a little bit more about that in a few moments. Other advantages of keeping the video short, beyond keeping students focused, and the ability to make the resources that you create more accessible to students. It's also easier for you as an instructor to prepare 5 or 10 minutes worth of discussion, to review the materials, to make sure that everything is prepared in a way that you're comfortable with recording, than it is to do the full 75-minute video. Plus, if there are technical issues and you do lose the recording that you've been working on, losing 10 minutes is far less disheartening than losing 75 minutes of video. And so you can just stop and remake that video.
So in putting together your videos, you want to make sure that you're thinking about things like you would a lecture. So there's no need for perfection. Your videos can be recorded just like you would give your lectures. There will be mistakes. You will need to correct yourself, and that's okay, right? So don't take time going through and editing all of your videos, because that's just going to be really, really time consuming, and it's not going to be a very useful way to put your time. So if you find a mistake in a video that has already been posted, be sure to address it in follow-up communication. You don't necessarily need to go through and edit the entire video, right? You might want to edit it before you post it for the next year's offering of the course, but for this current course, if some students have already watched the video, you want to make sure that you're posting something and addressing the error that was in that video to make sure that all students get that same messaging. Imperfection is something that students understand, and it's also something that makes us seem human, right? So we want to make sure that our students are seeing that we're also human and we're not perfect in putting together our videos.
One of the most commonly overlooked characteristics of online teaching is that the things that make face-to-face teaching effective most also apply to online teaching. So keeping learning objectives in mind when you are preparing videos, but also presenting those learning objectives to students up front so they know what to expect, so that they can be prepared mentally for what they're expected to learn, can both help the students in their learning, but also help you restrain the scope of a particular presentation to things that are on topic. Again, remind students about pausing and pondering, and considering answers to questions that you pose, or what would the next step in that derivation be, or how would you label this diagram? Teach as though you were in a lecture, but use that intentional pause to get them to do the things that you would have them do by pausing in the midst of a lecture, while still taking advantage of the efficiencies of video when you can pause recordings and magically the diagram appears. You might also choose to use a formative assessment method, a poll or a quiz, for a more formal check of whether or not they are following what you have been saying, in addition to having them write down their answers or things that are mostly for their benefit and not necessarily for your formative assessment purposes.
One of the really important things that you want to keep in mind is that you don't need to reinvent the wheel, right? So all of us are in engineering, or presumably we're in engineering. There are so many resources available to help teaching engineering specific courses, and don't be afraid to use them, right? That's one of the benefits of being in the engineering community, where we do have a lot of focus on engineering education. So don't be afraid to use another faculty member's online videos or demonstrations or virtual experiments. If it's going to help in your course, make sure you're using it. I'm sure that other faculty member that posted it online is happy to have you integrating that content. So as you're going through and doing this, you do want to make sure that you're giving credit to the person that has developed these materials. So if you want to use a YouTube video, rather than integrating it into your own lecture video, make sure that you're just posting it so that students are accessing it in a way that it was intended to be accessed. So YouTube has tons of useful resources that you can use to find videos or demonstrations on different engineering-based content. There's also Coursera and edX, your different publishers, and then knowledge aggregators. So in chemical engineering, there's a lot of different aggregated places where you can go and find a link of a lot of different learning material specific to chemical engineering education.
So as an audience, you all represent a broad range of disciplines in engineering. So we just wanted to highlight a couple of tools which just so happen to be published by our host for today, Elsevier. The first is novel.com. Novel.com, the way I view it is a source of full text reference materials that are made electronically accessible in ways that they couldn't be on paper. So that means things like interactive tables and charts and a range of other tools that are invaluable in courses. I use this in lower division classes as a way of getting physical property data as well as thermo and other kinds of properties that are not provided in their textbook, as a way of introducing them to some of the broader technical literature, at least as far as reference text goes. And one thing that you'll discover if you haven't revisited the sites for some of these tools, including Novel, is that there are a lot of new features that have been added over the years, and some of which you would be surprised at how useful they can be in an online environment, where you can step through how to use these tools with your students and then have them use these tools on assignments at home. Another tool from Elsevier is Compendex, which is actually a subset of Engineering Village, I've been told, but I've always known it as Engineering Index or Compendex from my first days of using this as a grad student in the 90s. It is a literature database that is focused on engineering disciplines, and as such, it covers a broader range of STEM sources. So it's a more focused database than using something more general than Google Scholar, and the advanced searching capabilities are far more powerful than what you will find with Google Scholar without becoming a scholar of Google Scholar itself. I use this in courses that I've taught online that involve term papers as well as design reports where they're expected to present what the current state of a particular technology or practice might be. And this is a way of emphasizing to students what a reliable source is, understanding that Wikipedia by itself is not that reliable source.
One of the important things that you're going to want to think about is how you can hold students accountable and keep them engaged within a course. So online coursework involves a learning process for students too. So this transition to an online course isn't something that always comes naturally. So by developing ways to hold them accountable, you can help to keep them engaged in the course and keep them progressing within that course. So typically the way you want to hold them accountable is through low stakes assignments. So what does it mean to be low stakes? It could be something that has a low grade impact relative to other deliverables. It could just be full credit for participation. So if they complete something by a specific deadline, they get full points. Or it could be a poll for students to, where they can go and respond to a poll during a lecture or ask a question in a direct chat to keep them engaged within that lecture. There's a lot of different simple ways to hold students accountable and keep them engaged. So some examples would be to have students upload their lecture notes from a lecture video. So for me, this is what I do with my courses. So in my courses, I put together an outline of my notes, essentially a scaffold or gap notes So I give my students the gap notes that I'm using as I'm putting together my lecture videos. I have them watch my video, fill in their own lecture notes. That way those lecture notes are shown and I can make sure that the students are really taking good lecture notes. And in reality, it's something that they should be doing anyway. So I'm not asking them to do an extra assignment. All I'm asking them to do is upload the lecture notes so that I can make sure they're watching the videos with my specific deadlines in mind. You can also have a quick quiz, which you can use to be able to keep students engaged in the lectures and make sure they're watching them on time. So this can be used for both reading assignments or for video watching. And you can also integrate them into live sessions. So some of our courses, we've put in PowerPoint slides that have the specific questions on them that we want students to go through and answer during a Canvas quiz. That way they have to be watching the lecture to be able to get the question so that they can answer that during a Canvas quiz. So this works for both synchronous, so live lessons, as well as asynchronous lessons that they're watching on their own time. And then you can have them generate responses in a chat window and then pick responses about which you want to comment. So if you're in a live lecture and you ask the question, have them send those responses in and then you can comment on some of them through the lecture. Another way to hold them accountable can be through accountability groups. So have students set up an accountability groups and give them recommendations on how they can run these groups. So they could send each other a weekly schedule, they could check in with each other on deadlines, or have meetings where they can talk to each other before exams. So different resources that you can use or technologies that you can use to make this happen. Slack is a really great resource, as well as Microsoft Teams is a commercial option that's become more available to a lot of us. You can also create or share tutorials on how to set a weekly schedule. So this was something that I learned a lot about over the summer. And because of that, I put together a video for my students on how they can develop a weekly schedule. So this is developed from the National Center for Faculty Development and Diversity webinar, How to Align Your Time with Your Priorities. And it's a video that I put together where students can, on a Sunday afternoon, think about all the tasks that they have to accomplish for the week, and then actually put that together in a calendar. So if you want to share this specific video, you're more than welcome. You can share this with your students, and hopefully they can use that to keep themselves on track for the summer and as they're going through their courses.
You know, whether students are being forced to transition online courses or you're just offering courses online as part of a regular schedule, problems are going to arise with students. And since presumably your goal in teaching a course is what the students need, you've got to recognize that there are always going to be additional problems, some of which, particularly in the current situation, will not always be appropriately documented in ways that we would expect in the past. For example, this fall, I would anticipate that many of us are going to be asking students to stay home if they feel sick, but they're not always going to feel sick enough to justify going to a doctor, and the doctor is not going to want to see them in all cases. And so having the documentation that a lot of universities require is going to be difficult. You might choose to use a flexibility request form like this to help identify issues and perhaps consider accommodations that are being requested for that particular situation. This provides a means of documenting what's happening and allows you to provide to implement consistent standards for all of your students in a way that is still fair and is going to be consistent with your syllabus, university regulations, and every other governing principle that you're obligated to. This particular form does come from Meg Grady at UK, and we'd be happy to share that file with anyone that would be interested.
So you want to make sure that you're providing students with tutorials. So as faculty, we've been provided with a lot of links to tutorials on lecture capture, on video conferencing, on LMS tools that have been created either by our universities or by these different software programs. Make sure that you're sharing the relevant elements of these resources with students. A lot of this will be helpful to them in addition to it being helpful to you as faculty. It's also helpful to share your experiences with students. So tell them your struggles, tell them how you learned to overcome some of those struggles. That way they understand that they're not the only one that's struggling with this transition, and they can see where they can improve their technology usage. Draw from the community. So a lot of tutorials have been put together on YouTube as well as from other universities. So make sure you're using those tutorials rather than recreating them on your own. So an example of a tutorial that we've made available to you, so you can see in your chat window, we've provided a link to this, is a tutorial on office lens scanning. So in engineering, oftentimes we have students completing problems where they're going to have to use a pen and paper to go through and solve a problem. And then when they're submitting their homework, they're going to have to take that hard pen and paper and convert that over to a digital file. So this is an example of a software that you can use to do that conversion of their solutions over to a digital file in a nice format where they'll get high quality scans of their work.
So it is important to set expectations for faculty, but many of you have probably discovered this during the past term. But it might be helpful to confirm that it really is the general characteristic of online instruction is that it does take more time than a face-to-face class, and the support time is also much greater than a face-to-face class. And also it's worth keeping in mind students have a lot of additional distraction elements available to them at home, some of which may be positive distractions, many of which are going to be negative distractions, the inability to find a quiet space, or the demands of parents or siblings or of others on their time. And so the way we design a course does become more important, and thinking through an effective design that is focused on engagement, interaction, reflection, and remaining active in a course is going to be important as you start looking at your next online teaching experience.
So one of the things that is kind of a big thing that we're dreading is potentially moving online with laboratory courses in the fall. So this is something that I'm very concerned about because I have 70 students signed up for our lab courses in the fall. So I just want to take a minute to talk about some possible strategies and things to keep in mind as you're trying to come up with ideas for how to move a lab course online. So before we get into this, I'm going to send out a poll. So do you expect to move a laboratory course or experiment online during your next term? So it's looking like quite a few of us are going to have to move some laboratory courses online. So 10 of us out of the group are going to have to move laboratory courses online. So what I'm going to say is I don't have all the answers, but here are some strategies that we can use to be able to integrate our experiments into an online setting. So one of the ways that we can do this, especially now that we have a little bit more time to prepare, is to record video demonstrations of the equipment. Right. So one of the big things that we want within a lab course is for students to be able to interact with equipment. Obviously, in an online setting, they're not going to get that experience of interacting with the equipment. So by recording a video demonstration, they at least get to see someone else interacting with the equipment. They get to hear what the equipment sounds like, get to see someone respond in real time to the behavior of that equipment, which can be something that is valuable. And it also gives them a little bit more understanding of how that experiment is run and how the data is collected. Another thing that you can do is provide students with previous or fictional data sets. So in doing this, you can have other students submit their data from previous semesters and you could provide them to students, or you could put together fictional data sets that you just kind of generate on your own. In doing that, you want to make sure that you're thinking about some other learning outcomes, such as sources of error in the data, right? So by providing students with data that was collected by a previous team, that data will have those sources of error integrated into it. So students will get to think about what potential error might have influenced the data and caused things to occur that weren't necessarily expected. So if you're creating a fictional data set, you probably want to make sure that it's not perfect data and it isn't perfectly modeled, because that doesn't give them those learning outcomes of thinking about what might be influencing that data besides just kind of your typical experiment. You can also use simulations and interactive demonstrations. So a lot of these are available online to us. So go and find them and use what's available to you so that students can get more of that interaction with a simulation. So oftentimes there's simulations and demonstrations where students get to pick different concentrations for a reaction and see what happens, or turn a valve and see what happens within the system. So they're getting that more interactive experience than they would with just interacting with the data on its own. Another thing that you could do is provide students with home experiments. So this could be in two different ways. One would be a pre-made home experiment where you as the faculty member say, go and grab these specific items that you have in your home and run this experiment with this that I've put together for you, right? So that's something where you have to know what your students are going to have available at home. So you want to make sure that you're working within the limitations of what they might have available to them. The other thing would be to have students develop their own experiments related to a specific real world problem. So this is something that I'm excited about, maybe even for an in-person lab, is having my students pick some specific real world problem and develop their own experiments related to that problem. So it's kind of your science fair style problem solving, but you want them to think about not only how can I measure this different variable that I'm interested in studying, but also how would I translate that to a laboratory experiment? So what lab experiment would allow you to take this measurement in a more accurate way? It allows them to think about sources of error in their homemade experiment. It allows them to interact with that equipment, do some problem solving that they might not get from some of your just interacting with data ways of bringing the lab home. A really important thing to remember as you're going through and developing a laboratory course in an online setting is to make sure that you're thinking about the lab learning objectives, right? So what are you hoping to accomplish with your laboratory course, and how can you effectively integrate those learning objectives into an online setting? So this is an example of a paper, The Role of Laboratory in Undergraduate Engineering Education. It's a Journal of Engineering Education article that goes through and lists out all of the different learning outcomes that come out of an engineering education laboratory experience. So in doing this, obviously you can't satisfy all of the learning objectives with a single experiment, but you can develop different experiments or different online modules that allow students to hit some of those different learning objectives within the course. So you want to make sure that you're focusing all of your online implementation of the lab on hitting those key learning objectives and developing strategies that allow you to hit as many of those learning objectives as possible. Another thing that's really important to remember that has helped to calm me down a little bit about this process is remembering that there are a lot of people out there trying to solve this exact same problem. You are not the only institution that's thinking about moving online for the fall, and you're also not the only program that has these labs, right? So make sure that you're seeking out other faculty within your discipline to be able to see what they're doing and what their strategies are, right? So in chemical engineering, AICHE has set up what's called a virtual community of practice, where we have a chemical engineering unit operations group that all we're doing every week, we're meeting for an hour to discuss different ways that we can move our lab courses online. So if you're in chemical engineering, send me an email and I can get you in that group. Right now, I think there's 40 or 50 faculty from all across the country that are working on solving this problem in chemical engineering. But I imagine that there are other disciplines that are doing the exact same thing. So try to find that community of faculty that are trying to solve this problem and make sure that you're using and learning from them as you're going through and trying to come up with your own method of getting your lab online.
Another challenge that we all have in teaching online is how do we do assessments in an effective and meaningful way? One of the first issues that we've had to address both this past spring and on an ongoing basis as we continue to teach elements of courses online is how do we deal with examinations? There are a lot of proctoring systems out there and none of them is perfect. Each one has vulnerabilities where a determined student is likely to be able to find a way around the restrictions that we put in place. But nonetheless, in a lot of cases, it's the best option that we have available. So one important practice with any online proctoring system is giving students a practice quiz that they can go through and experience the locked down environment. Whether that's the Respondus product where they're working from a web browser on their LMS, or it's ProctorU and you're working through a different process. They need to know how to go through that process, what it's going to look like, what are the issues that they're going to run into, what are the requirements, like do they have to have their camera on, and things like that, making sure that their computer is actually going to be able to handle what's required by the proctoring system, and whether their internet service is going to support it. Make sure that they have opportunities to take that quiz multiple times. This is more of a quiz just to see, can they read the equations, can they see the reference sheets, than it is to actually assess any learning. Now, with engineering courses, it's kind of rare that multiple choice exams are a preferred method of examination. Unfortunately, even though it's not a native part of online examinations through learning management systems, we've found some good workarounds. Since proctoring systems do allow the use of scrap paper, we have our students do their work on paper as though they were working on a paper exam, and they're required to submit scans of their work within 15 minutes of the conclusion of the exam. We do tell them that their handwritten work must support any submitted responses on the exam. So what I do is I will have some sort of an answer for each question posed on the online web-based exam. In cases where it's practical, it'll be automatically graded, but there's an explicit disclaimer that says that you've got to show your work, and having the right number in a box is not the same thing as having a correct solution, and credits can be based upon the work that's shown. It's important that you take your own exam. You've got to make sure you've debugged it, and debugging an online exam is a very different experience than debugging a paper exam. Not only do the problems have to be well designed and well written, but you've got to make sure that the things that you expect the students to see can actually be seen. Make sure that any reference materials that you've provided are indeed readable, that the equations appear the way that you intend them to look, and that you have things sorted and ordered in a way that makes sense. And the only way to do that is to log into the proctoring system and to view the exam from their perspective. So do take some time with that. It often takes several iterations to get it all in a form that you'll be satisfied with. The temptation to cheat is the same online as it is in class. In some cases, it can be helpful to have an honor pledge in place for that exam for schools that don't already have an overriding honor code. Again, that's not going to stop everybody, but in that pledge, you can set out specific expectations and give yourself a very clear basis from which to deal with violations of that honor pledge. We also recommend that you have a video conferencing based backup to proctoring in place, where if the proctoring system fails for a particular student, that you can pick up a video conference and proctor them through that. Using breakout rooms can also help you with larger classes to break them into smaller groups that can be monitored by you and your TAs if you choose to use this as a primary method, which some instructors have also done, but also to allow you to separate students from each other, but then be able to drop in on their particular breakout rooms and to observe any of the obvious signs of misconduct.
You might also want to think about alternatives to the exam to make sure that you're giving students the opportunity to show you what they've learned, but kind of taking away that ability for them to be able to work with other students or cheat as they're going through an exam. So different ways that you could give alternative testing methods. One would be consider using projects. So maybe you assign different projects to different groups where they go and put together a presentation. They can still get the same testing and assessment of their learning objectives, but you can do it in a project-based form. Another method developed by Josh Enzer at University of Delaware is called the SPIT approach. So this is used in other disciplines, but he's applied it in chemical engineering. So what the SPIT approach is, you first have the student solve a problem and clearly explain their approach, right? So solving the problem, that's something they could cheat on, but clearly explaining the approach is something that's a little bit more difficult for them to be copying and pasting from somebody else. Then they're asked to connect the problem to their life outside of chemical engineering. So they're personalizing that problem and applying it to a real world scenario. Next, they're asked to integrate it into the chemical engineering discipline. So connect that problem to their understanding specifically of chemical engineering. And then they're asked to think about the material that they've been tested on and create a related problem or prompt and go through, solve that problem or prompt that they've developed, and explain that solution. Similar to this, Margot Vigent at Bucknell University has had her students create a summative portfolio. So she did this for her spring offering of thermodynamics, where she asked students to take 3 different major concepts in thermodynamics and connect it to a real world problem. And then they went through and created a portfolio where they talked about thermodynamics in the context of this real world event that they wanted to do. So they could create their portfolio in any way. So whether it be a submitted document or a video, they were able to be creative in how they put together that final portfolio. And then another option would be to have them write and solve their own exam. So give them specifics on the different types of problems that you want them to write, and have them go through and create their own problem that tests their own knowledge on that specific content.
So we talked early on about communication and its importance in an online environment. And so it's appropriate we come back and revisit that topic because of how critical it is to the success of an online course. And in this context, we want to talk more about how do we follow up throughout the course with additional communication. You know, in addition to the sending emails and announcements, we still have to be interactive with our students despite the separation caused by teaching and learning online. It is important to continue to maintain some form of scheduled office hours. We'll do them with video conferencing. That should be self-evident. Consider using wait rooms in your video conferencing software if it's available, as a way of keeping meetings private when appropriate. So you can have everyone come in to a meeting and be placed in the waiting room, and then you can admit them in the order in which they arrived. And if you need to deal with something private, don't invite anyone else in. If you're going to do an example problem on what you think is going to be a commonly misunderstood concept, bring everybody in. So do what makes sense for your particular situation. You might choose to record the elements of those office hour sessions and treat it as kind of a bonus recitation period that will supplement lectures. And so if you're going to work that additional problem during office hours, you might choose to program it and to basically use that extra time together to emphasize concepts, techniques, or technologies. And students should know what to expect when they're going to conference with you, whether it's for a live class or for more of a one-on-one discussion. Do they need to turn on their camera? That's something that you will want to set those expectations before the meeting in order to avoid surprises. Another thing that's often a challenge when doing virtual office hours is having a writing surface. You know, if you're doing your office hours in your office, you have that whiteboard handy, or you can just grab a sheet of paper. That's not always as accessible in an online environment. So if you happen to have a document camera at home, that obviously opens up the paper element. You might also consider, if you have a tablet with a writing capability that maybe isn't your primary video and conferencing device, go ahead and log out of your conferencing software on that second device if your provider doesn't allow multiple logins. Zoom does not allow multiple logins, for example. And then join a meeting as a guest. And then you have a second screen that's available where you could be writing on a whiteboard while you are using your primary video conferencing platform for video and for audio.
So we mentioned before that in an online environment, your students are often going to have a lot of questions and you're going to get a lot of emails. So in a live class setting, typically students will come up to you after class. In this online environment, a lot of times student questions might go unanswered. So you want to make sure that there's multiple ways set up for students to be able to ask their questions, and that you want to make sure that you're clear in communicating with students about how best they should be sending those questions to you. So one way of doing this is to ask for email submissions. So if before an exam, 4 students email you with the same question, what you might want to do with that question is then take that question and post your solution to a discussion board. That way you're answering the question to all of the students, and all of the students have that information that they can use on their exam. You also might ask for posts to your learning management systems discussion boards. So consider having the students respond to their own questions within the course so that it's more of an interactive discussion board. But in doing that, you want to make sure that you're monitoring and correcting misunderstandings of the content. So if there's an incorrect answer, make sure you're going through and correcting that misunderstanding. Additionally, you can provide your own answers to those questions after a specific amount of time. So give students the time to allow them to interact on that question and discuss it, but then provide your own answer, potentially in a video rather than giving a written response. Another thing that can be really helpful can be to survey your students. So again, we talked about this before, but it's really important. A lot of times students aren't willing to voice their concerns, but giving a survey gives them that anonymous platform where they can ask their question or voice their concern. And typically it's something that can be pretty easily addressed, and you can make sure that you respond to those student concerns.
So we've presented a few of our favorite ideas that have been derived from discussions with colleagues, from our experience, as well as from the literature. We wanted to point out, though, some of the additional sources of great ideas and experiences in online instruction. And that includes some of the ASWE publications, including Advances in Engineering Education and the annual conference proceedings. Many of the disciplines represented here have journals that also provide a venue for disseminating educational innovation as well, and I would recommend reviewing those. And there are also some great projects and ideas at the Keen website at engineeringunleashed.com. We'd also like to acknowledge some of our contributors, Christy Goebel at UK, who gave a lot of great input as we set up an internal guide to teaching online at UK. She has taught an online and distance statics class for years and has had tremendous success with that. And then Meg Grady at UK for that form that we shared with you earlier. So thank you all for your attention, and we'll be happy to take questions.
Thank you both. That was great. So everyone, if you have any questions, please ask them in the question and answer queue. While we wait, I do want to remind everyone that each Wednesday and Thursday at this time, we have the engineering webinar series. So tomorrow we're going to have the EV for academia, bringing you some tips and strategies for students. So let's go ahead and take a look right here for some of the questions that we're having. So any advice on group assignments?
Yeah, so I can talk about that a little bit. So I had to transition my laboratory course online for the spring, and it was a big concern how to get students effectively communicating with each other in group assignments. And honestly, they did much better than I thought they would. So I think they really enjoyed, I had them set up Zoom rooms where they could interact with each other over video. And then I set up Slack groups for them. So Slack is kind of a team-based communication software. So I set up Slack groups for them so that I could monitor their communication. So for a lab course, we had data analysis sessions where they were all required. So I could have them check in during those data analysis sessions, and I could send questions that I had for those groups through that Slack messaging system. So Slack allowed me to organize all of their communication into a group that made it easier to communicate with all of the students. But big thing is making sure that you're doing peer evaluation. So making sure that they're being held accountable for participating within their group. I think that's something important. And make sure that it's worth enough points that if they're not participating within their group, they will be significantly penalized. And then make sure that you're following up with that. So typically I'll send teammate evaluations at multiple times throughout the project to make sure that if there's a problem, that it's been identified mid-project as opposed to just finding out about it when I can no longer make a difference or get that person to start interacting with their team.
And I took a different approach, or similar approach in some cases, for group projects online. Instead of using Slack, we did use Microsoft Teams, which has very similar but distinct capabilities. with some success. We actually discovered, or I discovered, that many of my students were using that even before we started using it formally. But the more powerful tool that I've been using in my face-to-face classes to some extent, and will be using it more aggressively, I guess I would say this fall, is using OneNote with its class notebook capability. What that class notebook capability does is it automates creation of a class notebook, which has 3 sections, one of which is for the instructor only, one of which posts read-only materials for your class, and the third is individual student sites where only the instructor and that student can view those notebooks. And you can have it create a fourth kind of site, which are group sites. And so you can gather your teams into groups, and they could be working from essentially the same whiteboard or same notebook, depending on how you want to view the metaphor. And what that has allowed me to do is, in classes where problem solving and group problem solving in particular is an important skill to practice in a guided environment, it allows me to have students work on problems where I can drop in and see their progress, see where they are having challenges, and then I can offer suggestions or ask the appropriate questions to help them identify what the next step in that problem would be. So I really am a big fan of OneNote Class Notebook, and it's available on all major platforms. It does have a little bit of a learning curve to it, but it's now stable enough to where I can recommend it for wide use.
Perfect, thank you. Another question that we have here is, what has been the most challenging aspect when transitioning to online classes?
So I think for me, it's been just maintaining student engagement. So getting students to attend discussions, attend office hours and things like that has definitely been a challenge. So whether or not it be live discussions where you're getting students engaged or just having them submitting assignments, you want to make sure that there's some way to keep them engaged within the course. And for me, I just miss the one-on-one interaction with students, which is something that I need to get over with, I guess, a bit more in developing the courses. So I want to come up with better ways to have live discussions where I can get students attending and participating. So a lot of times participation, whereas normally I would ask a question to the class and people would shout out answers. In a Zoom meeting, you ask a question to the people attending your Zoom meeting, and oftentimes it's just silence. So I need to come up with better strategies to address that moving forward.
For me, the biggest challenge this past spring was I'd already been flipping my classroom for quite a while, so it was that part of video creation was not a big challenge. What I was deliberate about, though, is if we are having 2 75-minute class meetings per week, for each class meeting, I chose to record no more than 40 minutes total worth of video, typically broken up into 3 to 5 pieces. And then we would still meet during the scheduled time for about 45 minutes. So we typically met for a little bit more than the scheduled time total, including the video watching and the live interaction. The biggest challenge with that was that the live interaction was not very interactive. It was me staring at a bunch of black squares, as I think many of you have experienced, I would guess, in a lot of your classes. And what I found was very effective as a means of getting students to respond to me was to initiate discussions using polls and quizzes. Not really quizzes, they were low stakes. They had been written into my revised syllabus where they had to participate, but questions about the content on the videos that they were expected to have watched. But an even better approach was using conceptual questions or concept tests. And that's a whole nother topic for discussion, easily fill up with another full webinar. But these are really challenging, non-computational questions that focus on an individual concept within a course area that includes distractors as possible responses, but is very well designed such that students are probably going to get it wrong, but it gives you the opportunity then to discuss the thought process in a way that will correct misunderstandings and improve student learning, particularly when used with the peer learning approach that Eric Mazer in physics from Harvard developed some years ago. And I would highly recommend his book, Peer Instruction.
David, if I could interrupt, we are running out of time. We don't want to keep everyone over the time limit.
Understood.
Sorry to interrupt, but everyone, thank you for joining us today. If there's any questions, we are happy to answer them or follow-up emails. There are some more questions, but we'll follow up with those. Thank you very much for joining us. And if you want to get the recording, or if you have any questions, please email me at wcoto, and that's COTO, @elsevier.com. Thank you, and thank you both as well. That was great.
Thank you.
Hey, so all right, everyone. Thank you guys so much, David and Sarah. I think it went really great. Actually, let me stop the recording.